All right, similar polygons. What do we say about similar again? Same but
different in size.
but different in size. That's right. Congruent means exactly the same. These two stars are congruent. But similar means they have the same shape, but their size changes. Now, what I want you to know about that is that what makes the shape hold the same is the angles. The angle measures don't change. This angle measure is the same, or it's going to be the same as this angle measure here. Okay? What's going to change is the lengths of the sides. The side measures are what's going to make it larger or smaller, but the shape stays the same because of the angles. Okay, so if you look at this, if I put it over here, all the angle measures are the same. Okay, they haven't changed. What's changed is what? The size. The size of the side measures. Okay, see this obtuse angle? It's the same as this obtuse angle, right? But see this side? It's longer than that side. So the key to being similar is that they have the same shape, which means all the angles, all the corresponding angles match each other. And then they have to have the same, that's the same shape. They could have different sizes, and that's about the side lengths changing. All right, so look at this right here, and write that up here. It's the same shape, but different size, just like we did on the other paper.
You can turn it on.
Alrighty. So here's the thing. Please pay close attention to this because this is going to affect everything for the rest of the chapter. And I'm going to show you some notations that will help you, some definitions that will help you, and then tomorrow we'll go into more detail. So right now. Draw that. Yes. Alright, with triangles. We had congruent triangles. And the thing about that was all the corresponding parts went together. Corresponding angles were congruent, corresponding sides were congruent. The only difference is that corresponding sides are going to have different lengths. A similarity statement. Do you have that written right there? For the similarity statement, what you do is you take one of the shapes and name it. Doesn't matter how you name it as long as you go in order. So I'm going to start at the A. And then I'm going to say A to B. And then what? A, B, and then what? C. You go, once you start to name a polygon, once you pick one letter, you go all the way around back to that letter. So A, B, C, D, E. Then you put the similar sign. Have we seen the similar sign yet? Okay, this sign right here is similar. It's like a congruent sign, except without the equals part. Because the equals means same size too. So similar means just the same shape. Now the thing is to make this one line up correctly. Excuse me. So if we say that A is congruent to congruent to F, and we say that B is congruent to G, and we say that C is congruent to H, and J, now I have to put 4, because they have to match each other but not match the other ones. And then we have 5. You mark them up that way. And that would be something that would be given to you. Either the statements or the markings like that would be given to you. All right, so once you have that, let's put this on auto. Then you can write up the order. So A goes with F, so we're going to line up A's first, so F is going to go first. And then B was next, so what would go after B? What goes with B has 2 marks? The G, good, and so on and so on. F, G, H, J, K. H, and I apologize that my writing, you may messed up. I'm going to redo mine a little bit smaller. Alright, so once you have that figured out, that is called the similarity statement. And on your homework, you are going to be writing a similarity statement. That's a statement of what is similar to what, using that similarity mark right there. Alright, now, two polygons are similar if and only if their corresponding angles are, what makes the shape stay the same? What's the rule about angles? The angles have to be what? Congruent, yep. The angles hold the shape, make the shape stay the same. The angles are congruent, the sides are not congruent. The sides can get bigger and small, but the angles have to stay congruent. The measures of their corresponding sides are, write this down, proportional. That's what makes them similar instead of congruent. Corresponding sides are proportional, meaning one's bigger, one's smaller, but they're all at the same ratio. So let me show you something. We don't have any similarity marks, but we're going to create some so that you know how to show what goes with what. And when it's triangles, it's a lot easier. But with these polygons, I'm going to show you here with these pentagons. Put one, it's not a congruent mark. We used to have a congruent mark where you just make a dash. But for similarity mark, what you do is you make a similarity, you make a similarity mark like this. A little squiggle to show that those two go together. Okay, how do I know those two go together? Because it said A and E are the first and last, and the F and K are the first and last, they go together. If I put two marks right here, then that's B to C, or A to B. What mark goes with that one? A to B, and then what goes with that one? F to G. Okay. Okay, but I put two little similar marks. They're little squiggles, like this mark right here. The similarity mark, that shows that those two sides go together, but they're not congruent. If they were congruent, they would have straight dashes. And then this one, BC, would get 3 of them. And BC goes with which one? GH right there. Okay, so those are markings that you need to know throughout the rest of this chapter. They show that the sides are not the same, but they go together. It'll be hard to fit 4 in here, but it is. Especially this one right here. Alright, I'm obviously going to have to squish them in, but there's 5 marks right there. Okay, but do you get the idea? Instead of putting congruent marks where two sides are the same, you put similarity marks where two sides are proportional, they go together. So to write a similarity proportion is the easiest thing. Okay, you have 5 sides, so you're going to need 5 ratios. 1, 2, 3, 4, 5. 5 sides, 5 ratios. 4 sides, 4 ratios. 3 sides, 3 ratios. I did that because I thought I could fit the squiggly marks in better with, I just started there, yeah. But as long as that one mark corresponds to the other one that goes right there. I was actually going to start here because I thought all those little squiggle marks would fit better over there. I just did it so that I can make it fit. Alright, so, here's the thing. I have one side, AB. What's easiest probably is to just go across the whole top. The whole top, make that the biggest shape. So what's next? I had side AB right there. What's next? Side. What's the next side? BC. And what? Oh, sorry. And what's the next side after BC? CD. And what's the next side after CD? ED. And I want you to notice that it's all the same up at the top. And after ED, you have EA or AE. It doesn't matter. So look, AB, BC, CD, DE, EA. They all go in order like that. Now here's the trick. You have to line up the bottom size, the bottom side of proportion, the bottom pentagon here with the corresponding side. And it's easy once you make the marks to go together. AB would go with which one? AB is right here. Which one goes with it? FG. And when we do this with numbers, easiest way is going to be doing it from least to greatest. But right now we have to find the matching sides. BC goes with which one? G. And CD goes with? HJ. Or JH, it doesn't matter. ED goes with? J. And EA goes with KF. Alright, now here's the thing. This is a similarity statement. Please highlight that or something, because when the questions ask you for a similarity statement, you need to know that what they mean is what is similar to what. When they ask you for a similarity proportion, they're going to be meaning, or sometimes they call it an extended proportion, they're going to be meaning what sides correspond with which sides. How does it look as a big old proportion or as a ratio? Alright, so you've got your proportional sides here. Let's do our congruent angles. Over here on the side, let's write congruent angles. Angle A is congruent to what? Yep. You got that from the markings. You got that from this statement right here. Angle B is congruent to angle G, and angle C is congruent to which one? You squeeze it on the side right there. If not, then squeeze it over where it says similar polygons. Okay. Angle C is congruent to angle H. D and J, and angle K with, oops, sorry, that's the other side, angle E with angle K. Okay, so this is what they mean when they're talking about similar things, and all your problems are not this long. This is just all the definitions that you need to know about it. That they have congruent angles. Notice I used the congruent sign on the angles. The angles have to be congruent so that the shape stays the same. But here, I did not use any congruent signs. The sides make a big old proportion, which means that there's going to be the same ratio factor for all of them. And the last thing you need to be able to do is write the ratio, the similarity ratio that compares the side lengths. Okay, that's the thing. There's got to be a consistent ratio from one to the other. So what you do is you look for two numbers that you know something about, two sides that you know something about. This 10 right here. 10 goes with AB. So I'm going to put 10 on top. What does that correspond with? What does AB correspond with? FG. So look over FG. FG is 8. So we can write a similarity ratio comparing these two shapes. 10 to 8 becomes 5 to 4. And that's the similarity ratio. It could also be written as 5:4. Written either way. Okay, so anytime you want to know or need to do something with similarity polygons, come here. These are the definitions that you need. What things have to be congruent? Angles, because that goes with same shape, congruent angles. What two or several things have to be proportional? Sides. That's what makes the length different, okay? So it's all about this. To keep the same shape, all angles have to be congruent. To keep the same size of the shape, the sides must be proportional. So you have that in a little box right there. Test that all angles have to be congruent. That keeps the same shape. And you have all your old ways to test that. If you test that all sides are proportional, what's that going to do? Angles makes it have the same shape. What are sides going to do? What did the side lengths do? As one side length gets bigger, what happens to the whole shape? Bigger. So the side lengths has to do with having different sizes. The angles make the same shape. The side lengths make the different size. That's what happens in proportional or in similar shapes. Okay, you do whatever it takes to show those two things. If it's true, we'll find the corresponding ratio, and we'll write a similarity statement. All right, here we go. Same shape checking for all angles are congruent. 101 is congruent to 101. That's given. This angle is congruent to this angle, that's given. Two pairs of angles are congruent. Do we know that E is equal to H? Way back. If two angles in one triangle are congruent to two angles in another triangle, what does the total have to be anyway? 180. So if you're taking 180 minus 101 and whatever this is, you're going to get the same thing as 180 minus 101 and whatever this is. Angle E is congruent to angle H by, it's called the third angles theorem. If you have two angles in one triangle congruent to two angles in another, then since the total has to be 180, you know that the third angle is going to be congruent. So number one, yes, we proved that right over there. Yes, all congruent angles, or all corresponding angles are the same, so these two triangles have the same shape. The angle holds the shape. Next, test that all sides are proportional. Alright, well, the easiest way to do this is to go from least to greatest. Least to greatest. Write down these three right here. Three sides, three ratios. When you're testing it, it's easiest to go from least to greatest. If they're asking you a different kind of question, different way, this won't work. But when you're testing it, go from least to greatest. So look at this triangle right here. What's the smallest side? Smallest side, least to greatest. 10, right? What's the smallest side over here? So make those two go together. The smallest side will correspond with the smallest side. Here, well, we can just write that 10. Now let's mark them first. You go with the middle side. 12 is the middle side. It gets 2 marks. What one over here gets 2 marks? The 18, 2 marks. Those little similarity marks show which sides go together. They're not equal, though. And then the third side is 17. That's the biggest side. What goes with it over here? 25.5. So when you're going to make your ratio, you just go from least to greatest. For this first triangle, it's 10, 12, and 17. For the bottom triangle, the smallest is 15, the middle is, and the biggest is. Alright, we're still checking to see that all sides are proportional. These are proportional if you reduce them all and got the same numbers, or if you could cross multiply them all, you get something that's equal. It's easier to just reduce them. 10 and 15, anyone know what that reduces to?
2.
Good. And divide by 6's here, what do we get? 2 over 3. Alright, now this one's really hard to reduce. Let me show you a trick. Okay? You don't want to deal with 25.5. Hey, focus here. This is our last example that we're going to do together, so get it, please, and then you will be able to try some on your own. You don't want to try to reduce 25.5. You want to turn that into 255. Do you know? Remember doing that? You just move the decimal over one place. But whatever you do to the bottom, you have to do to the top. So you make that into 170. So now you're reducing 170 and 255. Now you can sit there and reduce that. But there's an easier trick. What are you aiming for on the top? What do you want in order for this to be true? 2. Okay, so take your calculators. Take your, you got your phone right now because I just wanted this to go quickly. So if you need to use your phone, you can. I want to have a 2. Figure out what number will make that happen. In other words, do 170 divided by 2. 85. Okay, so if I do 170 divided by 85, I'm going to get 2, right? So what should I do in the bottom then? Divided by what? 85 again, okay? That's just a fast way to go and check it. Does 255 divided by 85 work for us? Yes. Get 3. Okay, well, it always works. Sometimes it won't be similar, but that's the quickest way to check it. Try to make your big number match the smaller numbers you're trying to match. Alright, so yes, they all are proportional. They all come to 2/3, 2/3, 2/3. That makes them the same. So next, if yes, write a ratio comparing corresponding sides and reduce it. Pretty sure we already did that. Alright, so the scale factor is 2/3. going from FEG to KJH. Alright, last thing, write a statement with corresponding parts matching using the similarity statement. In other words, that is the similarity statement there. So start with your first one and put it any order you want. FEG. FEG is similar to, oops. Be careful, put this in the right order. F goes with which one? J. Put them in the right matching similarity order. E goes with H, right? And G goes with K. Alright, so those are the 4 things you have to do. This is the test to prove it, and then this is what you can do with it. This is called a similarity statement. I want you to know that that's what it's talking about when they ask you similarity statement. I want you to know that that's what it's called when they ask you to do it.